I get here?
What is from now?
It's quite a long story, starting from September all the way to now. Okay, so we are in school, computer science, about to make a thing for the thing, yeah.
What a nice thing.
Yeah, it's a very nice thing. And the basic gist of it is that we have to build and model a pencil drone. In order to make a pencil drone, I have to use the engineering design process. There are 5 steps to complete this task, and I'll run through them in order. The first step is ask. By asking questions, I can set a guideline for myself and figure out what I have to do next. First question, how do I make a drone? Well, we've got a 3D printer right here.
This is our engineering expert here messing with the 3D printer.
Cool, but how do we get the thing to print what we want?
He's having difficulties getting it in the hole.
Wouldn't you?
Yes, I would.
We're going to need a model for this. In order to build a model, we're going to need a 3D modeling software. Hey, what's this? This program is called SketchUp. It's a 3D modeling software that's A, free, and B, easy. We could use a different 3D modeling software like Blender, but the thing about Blender is that the learning curve is straight up. Now, we've got our SketchUp software. Now, how do I use this thing? They're a long and arduous process that totaled about 10-30 minutes. I practiced with the program by making a whole bunch of geometric shapes. Cubes, cones, cylinder, other 3D things that start with the letter C. The most important question to me is, how do I make this thing fly? Well, we've got motors to do that. And for our case, we only have 4 motors per drone, so we're going to be making a quadcopter. Now, that little fact is important because we are only allowed to use 4 motors, and because of that, each motor provides an X amount of thrust. So the thrust is measured in terms of grams, so each motor can lift an X amount of grams. Because we have 4 motors, that is going to be 4 times X. So that'll be, the total thrust would be 4X. So say that the motors we have can only lift 2 grams each. That means that it'll be a maximum of 8 grams, because we have 4 times 2, 8. So what's going to be the ideal weight of our drone, and why does it matter? Well, you see, if a drone is too heavy, it won't fly. There's not going to be enough thrust to keep it going. And according to this handy-dandy website we have here, the ideal weight for a drone is about half of the maximum thrust. So that way, when the thrust is at half, it'll just hover there without much of an issue. So, knowing that our drone has 4 motors, each of them lifting 2 grams, and it'll max out at 8 grams, our ideal weight would be 4 grams. Alright, so we know what we have to do to make it, and now I have to figure out how to do it. For that, we need step 2, imagine.
Wave hello, Mr. Cohn.
The purpose of Imagine is to give us an idea of a final product. Now, I want my drone to look like one of the drones that we have, just to keep it simple. If it's not broke, don't fix it. So, here's what I want it to look like. Onward to make it look like that.
So make sure you save your information.
After step 2, Imagine, we have step 3, plan. There's a whole bunch of planning that involves this. Now, we've got our SketchUp program, we know how much it has to weigh. Let's keep it simple. I want to use basic shapes, so I need to know how to find the volume and weight of that. I need to know how much the material weighs per cube millimeters, because that's going to be the size of what we're working with. So I'm going to need the equations of a cube, a circle and sphere, of cones and triangles. I need to find out the mass, and for this matter, I'm going to use the simple final equation of volume times gram over volume. That will give me grams. Now, let's start the fun part now, making this thing. Step 4, create.
Next time, if you're not ready to solve it,
So, this is the part that everybody's looking forward to, create, where an engineer's design can either make or break it. So, in my case, I started with 100 millimeter by 100 millimeters square, giving me a total area of 10,000 millimeters. Then, I added 4 circles, each with a diameter of 20, subtracted by the inside circle, which has the diameter of 10, so radius of 10 and radius of 5 respectively. Now, this would then give me about 300 to the times pi extra area. So I added that to the 10,000 millimeters squared. Once I got there, I needed to find a way to make this seem like a zero. Because like, as you can see, I have like a giant square with circles. Alright, and then we're just gonna shave off some of the corner there, shave off some here. And a lot of what I'm doing is shaving things off. Adding up numbers in my head right now. I'll put those numbers on the screen, as you can see. And my entire plan is to get little shapes, and then once I'm done with these shapes, I can then just push it up by 1 millimeter by giving it an extra volume, and then just multiply that by the equation that we had previously. Now, when all is said and done, I'm going to have about 8,597 millimeters cubed, and the weight of the plastic we're using is going to be 0.00095 grams over volume. That's going to be 3 zeros. When I multiply it together, I end up with 8 grams, 8 grams, 8 grams, 8 grams, 8 grams, 8 grams. That's not good.
I'm gonna miss you. You're probably the best part of this class.
Alright, so my drone's too heavy. That's fine, because this is what step 5 is for. Yep, that's right, the engineering process has 5 steps, remember that. Step 5 is improve. I messed up somewhere along the way, but that's okay. That's what improving is for. Now it's time to fix this to make sure I can fly. This is version 1, well it's not even a version, it's more like a print. Yeah. Okay, so this is version 2. I made this with the final product in mind, but it's still missing something, and it had these weird lines here that I couldn't get rid of, so I decided to just scrap it and start again. This is version 4. It has little clips here, so we can enter the motors in. That's what the other 2 versions like before. If you're wondering why there's not version 3, we don't talk about version 3. Okay, this is the final definitive version of my drone. So here you can see the weight, 4 grams. Okay, it's time to start printing this thing to the 3D printer. Now, most drones take about 30 to 40 minutes to print. In the case of this particular drone, it's going to take a while. So, while it's taking a while, let's practice some crashing.
This is John. He crashed.
Not chat, I did not crash. I landed.
That was a crash.
That was a landing.
Ooh. He crashed once more. Try 3. Oh,
Did a flip.
you missed the hole. Internet seems to be down. Oh, but you crashed.
No, I landed. Congratulations. See?
Next up, soldering the motors to the receiver. Now we're assembling the drone. And here we are.
There's no more power.
Figure it out. I'll figure it out.
What is going on? Mohammed, stop being there. You're putting so much depression on me. Come on,